Mary Perry is a dear friend of mine, and I'm very excited for her to be on the Laracon stage for the first time. A little bit of lore about Mary is I host a podcast called Mostly Technical with my friend Ian, and Mary Perry. All right, we got 8 fans out there. I love that. Mary Perry had the first sticker on her laptop thanks to producer Dave. So Mary and I have been friends for a long time. She doesn't work with Laravel professionally day to day, but she came to Laracon for the first time 2 years ago and was just totally floored by the community and just continues to invest and be a part of this community. And that's one of the things I think is so special about this. And Mary is brilliant. She's self-taught. She's enthusiastic. Generally, she's a database person, which a woman after my own heart. But today, she is coming from Scranton, Pennsylvania, to talk to us about design patterns. Please put your hands together for Mary Perry.
Okay. Hello, Laracon. I had this. I had this whole entrance planned. It was like really elaborate. There's gonna be choreography. I asked some people to help me with dancing. There's like a different song, but I think I baroque something yesterday when I was playing golf. And I needed to have a more measured entrance, just get a little bit of rest. I'm just trying to compose myself because I'm new to speaking. Some of these puns are terrible. I'm actually stringing you all along. I can't dance. On that note, what's the good word? I'm Mary Perry. I'm from Scranton, Pennsylvania. I don't have too many interesting hobbies, but I like liking things. You may have seen me on social media saying nice things about a project that I think is cool. My handle is Cyprius. The first part is from the Arabic root cipher, which means zero or nothing or null. It's also the root of cipher. So I basically think of it as like false, and then I tried to turn it into an adjective, so it's like kind of falsy, which I think is an interesting concept. And here's an example of why. You could write a function that returns a Boolean, checking that an object has an attribute. But sometimes in real life, we find that true and false don't really satisfy every relevant case. So we can define a class that helps us to combine multiple checks for Booleans and make a more complicated assessment of whether the evaluation should be true or false. And this works really well, like in authentication, for example. And this is really all design patterns are, named solutions that you can reuse, that you've reworked to solve cases that you haven't encountered yet. But instead of all of this, if we were working together, I could just say, let's manage the access with assertions. And then you could say, skipping all of this, I think a guard close pattern would be a better choice. Because in some cases, true and falsy are all important, and so is the way you handle them. And I think the names of these patterns are really interesting, but maybe you don't. And I don't really think that that matters, because if you've worked with Laravel, you've probably used a guard class in one of your applications. And if you didn't have to event it, I'm guessing no matter what your background is, the first time you used a guard class, it worked pretty well, and it didn't take that long. Just really quick, to see a key for the diagrams that I'm using in this talk, you can go to ado.laravel.cloud. It's going to be more detailed in the future. It's very, very basic right now. And if you want to follow me for updates, you can check out my pin carry. I'm at Cyprius, and all my other socials are linked there. So without further ado, this is my talk. Much ado about naming. You already know that perhaps the best reason to use Laravel is its productivity. And what I mean here when I say productivity is that many of the problems that need to be solved when you're designing a web application are already solved and given to you for free. It takes about 10 minutes to set up a default Laravel application with authorization and even multi-tenancy, and also have a coffee. And because you're using Laravel, you probably already know not to try to solve every problem with first principles. Laravel is an entire ecosystem of solutions to common problems. And when you build with Laravel and its packages, you're benefiting from other people's mistakes and from their experience as experts. So this means you're probably going to ship faster while avoiding foot guns. All that considered, do you need to learn design patterns? Probably not. So you're already capturing design experience in a form so effective, you don't really have to think about it. And just mentioning the names of these packages that make up the ecosystem communicates the complexity of these solutions as well. Laravel core is full of design patterns, and your development experience with Laravel is full of their benefits. In the source code, you can look at it. It's concrete, testable, readable. These patterns are combined in Laravel's fundamental solution to the question of web applications, how to best return a response to a request. The answer is, from Laravel's perspective, the request lifecycle. And over the next 20 minutes or so, I would like to take you on a tour of it and point out some places in Laravel core where those patterns are used. The index.php file loads the composer-generated autoloader definition and then retrieves an instance of the Laravel application in Bootstrap. So the whole project of this first step section is creating an application. And we'll start with a singleton. The Laravel application is a singleton because it has a method which returns a unique instance. Application extends container among other classes, and the get instance function ensures that only one instance is ever returned when you ask for it. And when it needs to be created for the first time, set instance takes container contract and overrides it. A container contract is the interface that defines the required parts of the instantiation, and your instance of the container implements it. Application also has other methods that are inherited and overwritten from these interfaces, and they actually work when you get your application running. In the contracts directory, in the container.php file, we're going to see the container contract, which has bind, which doesn't do anything until the container class overwrites the definition of a functional method, and the class knows how to find and return the data it needs, which can be stored and modified without modifying the singleton itself. And the unique application object can be returned using application's getInstance method, which we just saw. So there can only be one in a singleton. It uses an interface by inheriting and overriding it, and it knows it's the only instance. Many of these services are factories, which is a really good pattern for if you want one of a group of products, but you don't know which one at a given time. So in this factory, the product ultimately determines through the creator and the concrete creator how we're going to get a concrete product, which in this case is going to be sessions. So this is where the session manager is registered, and then the result is going to be stored in the service container as a singleton. This is an example in the session manager where we're taking a instantiation of one of those concrete factories and creating it with build session. This kind of cookie cares about, this kind of session cares about cookies and expiration. And there's a very similar one where we're going to take a database session handler and it cares about, the table and the connection, et cetera. So in general, a factory is a class that provides instances from a group of subclasses. They have a method that's determined at runtime. It has products, which are similar objects produced by a factory and used by your application, and it uses an interface or contract to give instructions of those similarities and ensure that the similarities are there. Speaking of services, if you need immediate wormhole-like access to the service in the service container, you can use a facade. The diagram for a facade looks different from other patterns. Generally, facades hide complexity while providing a few simple access points like an API or an interface. Here's a classic example. If you're using a compiler, you pretty much only need the compiler method, unless you're writing one. But then you'd probably be like using Go or Rust, by the way, and your editor would probably be NeoVim, by the way, and you'd be running like Arch, by the way. So I'm really just speculating wildly here. A facade, in a word, is encapsulation. Hiding complexity in a system makes the code which interacts with that system simpler. But Laravel gives you more than a design pattern of a facade. They're more specific, and they give you access to a service provider class from anywhere. Real-time facades, you could get static access, you could do custom facades. They are an awesome vanity plate. They look fantastic on a hat. And if you learn them really deeply, then you can stay up late into the internet arguing with strangers about whether anyone should ever be allowed to use them. That's not nearly as productive as actually trying to write code with them and seeing what the service container is capable of, but you could. After first steps, the request is going to be sent through the handle function of the kernel, either the HTTP or console. Web requests, we're going to kind of focus on now with the HTTP. And if you don't use a facade, Laravel will find the appropriate classes via inversion of control. This family of patterns provides instances without requiring the controller to know about them or be directly responsible for them. So it inverts the control flow, increases decoupling, and frameworks are a really good use case for dependency injection and inversion of control, and so are event handling systems. And Laravel has a lot of events. There's 4 varieties of inversion of control, and Laravel arguably uses all of them. But we're just going to talk about dependency resolution really quick. The service container uses bind and binding-like strategies to resolve and auto-resolve dependencies for you, so you never have to experience dependency hell when you're using Laravel. You've probably seen code like this in a controller. And whenever you call construct either implicitly or explicitly in Laravel, it's a hint that some dependency injection is happening. So anytime a service is resolved, we can see make or build happening. With make, we're going to see the dependencies resolved. Laravel will go through the resolve function and return and iterate through the dependencies, making sure that they're all created, or throwing an error outside of your controller so you can avoid catastrophe or ensure, as in most cases, that the object you're trying to create can be created. The method is resolved when the controller is actually called. And there's a lot going on behind the scenes. It's for a very short amount of code. I really love to be able to see the complexity of the controller and know what's going on there. It makes me very happy. Then there's a builder pattern I'm going to talk about in terms of middleware. In the bootstrapping phase, we saw this index entry point, and the project of this phase is to instantiate an application. So now we're going to talk about how the middleware gets created. The builder pattern is a solution when we want to build a complex object using the same construction project, but get a different representation every time. The director in the builder pattern is a method which works to build the product, and the director of this is going to be the kernel, which is responsible for passing the request through the application's middleware stack. And the plan is to send a request through this pipe object, which is configured with whatever middleware is going on in the application. The order the middleware occur is important, and when you modify the kernel, you can choose different orderings based on the type of request that you're getting. The pipeline needs to send the request through these middlewares, which modifies the request as it passes through. And the concrete builders or individual middleware inherit from the middleware interface, and eventually a product is specifically configured. In this case, it's the request object. If none of the middleware stop the request from continuing during this pipeline, then the request can be routed to the appropriate routing controller with the right HTTP verb. So in general, the builder pattern reuses functions in the same project for different object representations, produces complex objects, and the build steps are managed by a director. Next, the service providers are loaded. I assure you this is very important, but I don't have time to elaborate on it because we're down to 8 minutes. So. Next is routing. During routing, service providers are registered, and the request is going to be handed off to the router for dispatching. My favorite use of Laravel is eloquent, and a close second is collections, which is also kind of eloquent. Collections are a type of iterator, and database enjoyers may like to know that another name for this pattern is cursor. Route collection provides a lot of functionality on top of listing the routes in our application. So here's another diagram. The client in this case is going to be the Laravel routing mechanism, and our iterator is actually the iterator aggregate interface that's from PHP in general. This gives us all kinds of things that we might want to do with a list. The abstract route collection is going to collect all of the routes that we have listed in various route files like web PHP or auth PHP or API PHP if you have one, or a custom one. And then we have this object that can be returned and get routes with more specific behaviors that we have decoupled but can use with that object. That gives us a lot of additional functionality. Specifically in the routes collection, we can use this to compile routes, support subdomains, name routes, group routes, and middleware, use fallback routes, all kinds of things. And it's because of this decoupling. So in general, iterators let you access the elements of an aggregate object, avoid exposing the internal structure or bloating the list too much, and traverse the list in different ways by defining different ways of traversal for different purposes. It's a combination of the routing and the verb which determines the request needs from the container, and that brings me to the strategy pattern. Generally, a strategy is an interface to be inherited, and it happens in some context from which it's decoupled. The strategy has an interface which defines some behaviors or attributes, and the strategies are all supposed to have, and then the concrete strategies overwrite them and do slightly different things for different cases. I already showed you at least 3 strategies, and you can find this all over Laravel. It's generally just a good life choice. In the context of the controller, methods return views, and those views are decoupled from the controller, the request, the route, and the verb. In the context of the application, all the middleware have a handle function, and the behavior is decoupled from the middleware pipe and the service container. And in the context of a service container, service managers can build unique sessions by parameterizing a construction of the concrete factories with the service manager. So strategies maintain a reference to the strategy object in a context. Concrete strategies inherit from the interfaces in a strategy, and then it implements that behavior as it sits on the strategy. And using interfaces is good. So we've reached the point of finishing up, where the response travels back outward through the route's middleware, and the application has a chance to modify or examine the outgoing response. The command, also known as the action pattern, takes a behavior we may have implemented in a method and stores all the information we need to execute in that object, which can be parameterized by the object that executes it. So this is an example of reification, the process of turning some process into a first-class object. Here's an example. The application receives the action as a parameter to its destroy method in some controller, and the action instance in that controller is invoked when the controller gets hit by a request. And that destroy method includes calling the handle method on the action, which contains a reference to the part of the application that knows how to handle the action. In this case, it's going to be a database. It's typical for a strategy to look like this, the creation of a receiver and then passing the receiver as a reference on instantiation of the action. But in Laravel, because of dependency injection, it might actually look like this. So let's look again. In the context of controller, it's decoupled from the service container, which functions as a client in this example. The destroy method invokes a delete action instance, which shares qualities of the other actions, including a handle function, and that references the receiver of the action, and the receiver knows how to actually get the job done. So in this combination of actions on top of all the strategies and controllers is very powerful and flexible if you think about it. But if you're also seeing this and you're thinking, well, I've structured my code like that before and I didn't mean to use a pattern or know the name of it, then welcome in. It is awesome to feel like you invented a pattern for yourself. It means you're onto something, and you can use that name to talk about it with other people who already understand why you're so excited about your solution. The command pattern is useful when you don't know what the action is going to be or what the receiver is going to be. It encapsulates the request as an object, which contains an execute operation, parameterizes clients with requests, and supports undoable operations. It's also super good for logging. And then after a request has occurred, most of the time changes will have happened in the state of your application. And the observer pattern lets an object called the subject update other objects when changes happen. Subjects need to have a way to know about and notify their observers, the classes that are going to be updated. And eloquent models can attach to observers using a static observe method in Laravel, and observers can be a class property. Dispatchers help a specific model, like team, manage their observers when state changes, and they're identified through reflection. They need to have specifically named functions, but they can access state temporarily for this purpose and define their own behavior, like, for example, logging when a team gets created or deleted. So as your request behavior is ending, you have a lot of objects that weren't directly affected, which are updated to when it's a state in a different object changes. And this pattern allows you to store those changes in objects called events, which benefits subsequent storage, logging, and other cool stuff. This is really cohesive. What I find so beautiful about Laravel is the choice of patterns it uses, the expertise demonstrated in the way that it solves the web's classic problem. How do we handle a request? The framework is extensible not just because these solutions adhere to the terminology of patterns, but because the code is implemented in ways that have been proven to work. And code that is reusable and has been proven to work tends to acquire names. These implementations are not always canonical or classical, but they are thoughtfully designed in ways that invite us as a community to participate, to learn, to read, and to contribute. Designing object-oriented software is hard, and designing reusable object-oriented software is even harder. Projects and processes we manipulate are unique, but experienced developers who have solved similar problems have found working solutions in the recurring patterns of classes and many object-oriented systems. These commonalities and the solutions to these problems allow us to put forth design patterns and to name them. And it gives us the language to discuss solutions with other people who know about them and express and recognize those solutions more quickly. For example, there's usually 2 S's in classes. But the variances in each system we design means that the details of our implementations and their grammar and the combinations of our business logic should not and often cannot be classical. They help a designer to get a design right faster. They speed up communication, reduce complexity, encourage documentation and readability. Their definitions describe real systems, but they're almost never exactly what they claim to be. My opinion is this: learn the names or don't. The right tool, architecture, and implementation is always specific to what you're building. Design patterns are just one way to talk about design that we can agree solves some problems. But whatever you're building, I hope that you're talking about it. Because ever since I started talking about it and liking things online and posting about it, my life got a lot better. So I'll leave you all with a final blessing. Laravel forever. Thank you very much.
Wow. Are you kidding me? That was incredible. That was your first big Laracon talk. That was incredible. And here is your Artisan jacket.
Thank you very much.
That was unbelievable. Give another round of applause for Mary Perry. So, a couple of questions. The first is not a question, it's a statement. We had many people that tweeted about your puns. So the puns worked. Everyone loved the puns. So good job there. I guess
Music to my ears.
Yes. My question for you is, what appeals to you about design patterns? Because you've obviously gone super deep, right? Deeper than probably most of us have gone. What is it about those that appeal to you, and where did you look to study and learn those things such that you could identify them in Laravel?
I like the idea of naming things and of the ways that we use grammar to name things. So I heard Jake Bennett's State Machine talk when it was in Nashville in 2023, and I thought it was so interesting that we could give a 30-minute talk that I had to spend a couple hours going back and learning more about to understand and describe everything that was going on to people who are artists that understand it in 2 words, just state pattern, you know? So I started really diving deep into it. I read the Gang of 4 book. I read a small talk book, a couple of articles online, especially the inversion control articles are better there, and I just kept going with it obsessively.
Yeah, well, it worked. That was the best deep dive into the Laravel lifecycle that I've ever seen. So well done. Very proud of you. Y'all give it up for Mary Perry.
Thank you very much.
Good job.